Cool. Some of these things are not always necessary to do. In fact, there are occasions where I might only need to make a very little table, especially if I figure my number of positive and negative zeros first. And I'll go through that kind of as we work through the problem. I definitely want to find the zeros, find the y-intercept, and find the mins and maxes. If I can find those three things, my graph can be done, sketched very quickly, very easily. The end behavior and the making a table and number of positive and negative zeros, those things are just maybe helpful. Because if I can't put it together with these things, a table of values or a table of points can help me finish off pieces of the graph. This guy here, knowing how many positive and negative zeros, even though it's not necessary to do, I always do it. And I always do that because if I know that, I know where to stop. And I know what to look for, and I know what table of values to make, all of those things. So again, not a have to, a recommended. And then we can use it to find the zeros. The y-intercept is probably the easiest thing in the world to do. And then the mins and maxes come from taking our second derivative. Or our first derivative, I'm sorry, setting it equal to 0. All right? End behavior, again, is just one of those kind of added bonuses. And so I think about the functions. Cubes have down on the left, up on the right if they're positive, flipped if they're negative. Fourth powers are same direction, up positive, same direction, down negative. And that's all I mean by end behavior. And so I just want to keep that in my brain as I'm sketching this graph. So this is what I know for my first one. I know it's going to look like this. The other option for it could be a twist in the graph, which happens occasionally. But I know this because it's positive, and there aren't many other ways there aren't any other ways a cubed function can look. These are the only two positive cubed function options. Knowing that, again, helps me figure out when I start to put these things together. Okay? So I'm going to start with, like I said, my positive and negative zeros. And so for positive zeros, I have 1, 2, 2 or 0. For negative zeros, I have 1 for sure. All right, so to find my zeros, I need to factor. This is not something that I can factor easily. So I'm going to make a table. And the table that I'm going to make, or I'm going to start with, is the negative table. Why? Because I am guaranteed 1 negative 0. So this is just me sort of streamlining what I do. I can't factor. That's a great way to find zeros. So I'm going to have to make my synthetic table. I'm going to kill 2 birds with 1 stone when I make this table. Okay? The 2 birds that I'm going to kill with 1 stone when I make this table is I'm going to find a few points and look for my zeros along the way. So I'm going to start very organized. This is 1, 0, negative 3, 2. Don't forget the 0 because there's no squared. I'll start with 0, I'll do negative 1, I'll do negative 2, I'll do negative 3, and I'm going to just start working through that table. Do you remember us making this? We could find between zeros when we did this. I also might be able to find exact zeros when I do this. So I'm going to start plugging my stuff in, very organized. If I plug in 0, I get 2.
Then I multiply and add, multiply and add, multiply and add. Do I get 4? 4, yeah? Okay. Multiply and add, multiply and add, multiply and add. Sweet. I found my -0. I do not need to use this table anymore. Done with it. I have a 0 at 0, -1. I'm going to depress this polynomial and see if I can factor. Looks like I can. X minus 1, X minus 1. Yes.
Why is it -1? Yeah, that's what I was just wondering too.
Instead of -1, 0?
Instead of -2, 0.
-2, 0? Because I don't know, because I have no reason. I have no reason whatsoever why I made such a horrendous, awful mistake. Nothing. Got nothing for you. All right. Thank you. So -2, 0 is what I really meant. All right. Are we good with everything else, though, other than my big full pot? So I can solve these. X is 1, and it actually is 1, 0, and it shows up twice. That means that this graph bounces at 1, 0. It goes through -2, 0. It bounces at 1, 0. I don't know if it bounces as a low point or bounces as a high point quite yet. I have an idea, but I'm going to keep that in mind when I graph. It bounces here. Okay? So I have now done parts 1, 2, and 3 to the extent that I need to do them. 1, 2, and 3. And you'll be given this list when you take your test, so you have an idea of things to look for and things to do. Okay? All right. So I've got all my zeros. I've got the 2 positives it said I was going to have. I've got the 1 negative. Now I'm going to find my y-intercept. Y-intercept is always the easiest thing to find. The y-intercept happens when you replace x with 0. If I think of this, it's f of 0. 0 cubed minus 3 times 0 plus 2. It always ends up being the constant at the end, because anything with an x, when I plug 0 in for it, is going to disappear. So I end up with the constant at the end. My y-intercept is 0, 2. Again, found that pretty quickly. So a lot of space, but I didn't spend a whole bunch of time yet graphing this. Now I need to do the stuff from last chapter, and that's my mins and maxes. So let's see if we can remember how that works. This is step 5. To find your relative extrema, your mins and maxes, you take the first derivative and you set it equal to 0. This one factored nicely. There are occasions when it doesn't, but this one did factor nicely. And so my x's are -1 and +1, and I'm going to make my f prime chart. Does that ring a bell a little bit from last chapter, hopefully? Now I do test points and decide if it's a max or a min. So I'll plug in something here like -2. That's +3 times -1 times -3. That's going to be a negative times a negative. Essentially, that'll be a positive region. My graph is rising there. Then I can plug something in like 0. It's going to be 3 times 1 times negative 1. That's going to be a negative region. I'm dropping that. Then I'll plug in something like positive 2, and then it's positive all across the board. That means it's positive in that region. So I know I have a max at negative 1 something. Here's the beauty of those tables. I already know what negative 1 is paired with. I don't have to plug it back into the table. I've got that one already. So my max is at negative 1, 4. I did not do a positive table, so my min is at 1 something. I'm going to have to go back and plug that one in. The math isn't too terrible, though. So I can either put it in the table, or I can just do that math. That's 1 cubed minus 3 times 1 plus 2. 1 minus 3, negative 2 plus 2, it looks like 0. This makes sense to me. A min is a low point. My low point is at 1. It's where it changes direction. 1 is also a 0, and it's a 0 that we said is going to bounce. So my min and my bounce location all kind of come together. All right. Now I just put it together. I have an idea of what it looks like. I know where the zeros are. I know what the end behavior is going to be because of a positive cubed function. I know where it's going to change direction. I know where it crosses the y-axis. And so I'm just going to, like I said, put all this stuff in. I'm going to approximate negative 2. And I just approximate. I don't go crazy about where it is. I just try to put it in the right location. Negative 2 is to the left of 0, so I'm going to cross at negative 2. And then my other 0 is at 1, so I'll put a point there at 1. I also know 1 is a min, so I'm going to make a low point at that min. I also know it crosses the y-axis at 2, so I'm going to approximate 2 there. And I also know that it has a high point at negative 1, 4. So negative 1, 4, I'm just going to put a rough estimate about where that is and make that a high point. Now I just have to put it all together. This end cannot come down again because I have no other location for it to cross the x-axis, so its only option is infinitely up. These are smooth curves, so I'm just going to connect the points to the pieces I have. From negative 2, it can't curl back up again. I don't have another min. I don't have another location for it to cross the axis. I know what a cubed function looks like. That's going to drop infinitely, and I'm done. So you see why there is a lot of room to work, because there are things that you need to find. But again, once you put the really important things together, the zeros, the y-intercept, your mins and your maxes, as long as you know what a fourth or a cubed function look like, those pieces of information can be put together. Anytime you get pieces of information and you're like, man, I can't even see where this is going, then I would maybe find a few more values and start plotting those points. Okay? Any questions on number 1? And maybe right now you don't have a question to formulate because it's still sort of soaking in, and that's fine. But let's go through and take a look at problem number 2, see how things go. Another cubed function. However, this one is a negative cubed. I know what positive cubed looks like. I know what negative cubed looks like. So this graph will look like that. Like that. Jeez, no, I was not drinking before I came to work today, I promise you. Or like that. Hey, sheesh. All right. Idea of how it looks. Off to a strong start. Y-intercept. I'm going to get that guy out of the way right away super fast. How did I know that? Am I magic? Yes. No, I wish. No. Remember, the constant at the end is my y-intercept. It is the point that when x is 0, I'll see it in my table as well. Okay, then I'm going to do positive and negative zeros. 1, 2, 3, or 1 positives. And positive, 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 no negatives. Okay? So I'm not going to make a negative table this time. I'm only going to make a positive table. And so I'll start positive, and again, I will start very organized. Negative 1, 3, negative 3, 1, 0, 1, 2, 3. I just always sort of start by putting a few on there. So, negative 1, 3, negative 3, 1. That's, remember, the 0.01. I already got that. It happens to be my y-intercept. Then I'll do my 1. Multiply and add. Multiply and add. Multiply and add. Score. I found another 0 right away. So I know for a 0, aka my x-intercept, those two things mean the same thing. That's the interchangeable name that we have. I've got one at 1, 0. Super. Okay, now I can bring this down. Negative x squared plus 2x minus 1. I'm going to factor out a negative 1, x squared minus 2x plus 1, and then I'll factor this. The negative 1 is a non-issue. This is factorable again. X minus 1, x minus 1. It turns out that x equals 1 2 more times. So I have 3 zeros at 1. Which means to me, this is a twist. What is a twist? It's going to look like that guy, the one I just circled. It's more instead of, okay, or in this case, instead of this, more of this. Okay, you get what I'm saying. All right. So I've got my y-intercept, I've got my 0, I know there's a twist. If my graph looks like this and I know there's a twist in it, are there any mins or maxes? No, there aren't, okay? And if you remember that, you don't have to do that. We know what it looks like and you don't have to find your mins and maxes. I already know that there aren't any. I can put this together with a few points. But I want to show you what it looks like when you do find it, okay? Yes? Yep. Yep. Yep.
Is that like a 0, 0 point?
Nope. It's a nothing. Because what we do is we set everything equal to 0. Can negative 1 and 0 be the same thing? So it's like a non-issue. Okay? If that were an x, then we would have a 0, 0. Okay? All right. So, like I said, I know what this graph looks like just because I remember, and I don't expect you guys to remember all of those things. So let's say you didn't think about the twist thing. So I'm just going to follow the rules, and I'm going to find my derivative. So f prime of x is negative 3x squared plus 6x minus 3. I'll set that equal to 0. I'm going to factor out a negative 3. So that's x squared plus 2x plus 1. Holy cow, that looks really familiar. Nope, minus 2x. Minus 2x plus 1. That looks even more familiar. We just factored that one over here. And so this factors to x minus 1, x minus 1, and again, my point on my graph is just 1 on my f prime table. So f prime at 1. Again, the negative 3 is a non-issue. I'll do my test points. I'll plug in something like 0. And so that's a negative, and a negative. The negative 3, the negative 1, the negative 1, that's a negative region. That means my graph is decreasing. Then I'll plug in something like 2. That's negative 3, 1, and 1. Also a negative. My graph is decreasing again. That's what the twist does. So it makes the graph drop, sort of slows down, shifts, and then drops again. When we were working on this, I said it's not unheard of for you to get all the same throughout. We saw a lot of sign changes because we were actually looking for mins and maxes, but it doesn't have to happen that way. Okay, so at this point, it doesn't seem like I have enough, but I really do. I cross the y-axis at 1. I have a twist at 1 on the x. I know what my end behavior is. This thing equates to kind of coming down and then slowing down and then dropping again. So it sort of has that feel. That's a twist. Okay. This has to come through this point. It cannot turn around and come back down again. It can't. There's no way it can, because we did not find a max. So there's no turning point over there. We also did not find another 0. There is no opening for it to cross. The only place this can go is up. And same for the other side. 2 points does not seem like enough. But to cross the graph, it needs openings. There are no more on the x-axis. All I can do is drop down. Let's do a fourth power. We're going to do a fourth power, and then we're going to do one on your homework together. Because on your homework, it actually has some between zeros, and I'll show you what those look like, and then I'll let you guys do one on your own. Okay? All right, so here's my fourth power. Positive fourth powers could be W's, especially if it's a real symmetric kind of looking equation. It could have a twist or a kind of lopsided sort of W look. It could be lopsided the other way. It could also be, no offense parabolas, a fat parabola. Meaning it's like wider on the bottom. It takes longer to start moving up. So these are the choices of things that I'm going to look for. I might find 2 mins and a max. I might find a twist and a min, and that could come in 2 variations, or I might only find a min. That's it. Those are all my options for fourth powers. When it comes to taking your test on this, you will be able to make like a note card that will draw out what do fourth power graphs look like, so you know kind of in your mind what they are, what you're looking for. I'm going to start with my positive and negative sign changes. Actually, I'm going to even easier start with my y-intercept. What's my y-intercept? Great. Like if you can do nothing else, I hope you can find the y-intercept. If you're like, man, there's no way I'm going to remember this, find the y-intercept. Okay? Positive and negatives. Positive 1, 2, 2 or 0. Negatives. No sign changes at all, so 2 or 0. When I did the last ones, I very nicely found pieces of information that were usable. Like I found a 0 right away, and I was able to factor and I didn't have to go too hot and heavy into my table, and I could start with a table that I knew something for sure. This one leaves a little bit more to my thought process, kind of. I'm thinking, I don't have anything guaranteed. Are there zeros? Are there no zeros? Okay. So the only option I have is to pull out a very, very organized table of points and see what I find. So for the positives, I'm just going to make this table, and I'm going to make this table until either A, I find a 0, and then the second 0, or B, I get to all the same signs along the bottom, okay, or along the values. So 0 is 6, that would be 1, 0, negative 5, 0, 6. Multiply and add, multiply and add, multiply and add, multiply and add. Keep it coming. Yell at me if you see something wrong. Anybody agree with me? Or are you just writing down my numbers? You know not to trust me. Do you see the things I pulled earlier? Double check and call me out if you... I didn't really find anything here, did I? The only thing that I kind of found is that it looks like it must change directions between 1 and 2. But does it go through the x-axis and come back through between 1 and 2? I'm not sure about that. So I'm just going to hold out on those points, and if worst case scenario, I just plot a few of these points and I connect them to make it look like I want it to. Okay. So again, I just found some points here. 0, 6 is a point on the graph. 1, 2 is a point on the graph. 2, 2 is a point on the graph. And 3, 42 is a point on the graph, although I'm not even going to draw 3, 42 on the graph because it's way too high. Okay. Now I'm going to do my negative table. Same thing, I'm just going to be organized, and I'm going to see if it gives me any indication of anything. Again, I'm going to do a few starters there. Don't forget, a negative table does not mean you change the signs of the values or the coefficients. It just means you plug in negative numbers. So 1, 0, negative 5, 0, 6. And go through the process. Multiply and add. Multiply and add. Multiply and add. Multiply and add. I sort of see some similarities between this table and the previous table. 1 and negative 1 both have the same value. I'm going to see what happens with negative 2. Negative 2, negative 1, 2, and 2. Looking pretty similar, looking pretty symmetric, looking kind of mirror-ish reflective. Multiply and add, 9, 4, negative 12, negative 30, so 36, 42. Okay? How do I interpret this? Just the way these things look, it could be fat parabola or it could be this first guy. How am I going to tell which one? Mins and maxes. It's definitely not a lopsided guy because so far everything looks real symmetrical. Right? What if you're, again, like, I don't know if I would think that. Don't worry about that. It's not important to know that. It's helpful, but it's not necessary. It's not important. So let's go ahead, bless you, and let's do our first derivative. So f prime of x is 4x cubed minus 10x. Does that seem reasonable? I'm not happy about it because that doesn't look easy to factor. I'll set it equal to 0. I'll pull out a 2x. That's 2x cubed minus 5. Squared, thank you. Yep, 2x squared minus 5. So 2x is 0 when x is 0. And 2x squared minus 5 is 0. I'm mathing fast, hey? Like lightning. Okay? When I solve for x, not forgetting my plus or minus, rationalizing the denominator. Makes me want to throw up a little bit, but I'm okay. I can handle it. I just need to know about c's where this is. If I were to take a lucky guess, I'm going to assume it's somewhere between 1 and 2, and somewhere between negative 1 and negative 2.
1.58.
Okay. So this is roughly plus or minus 1.58. Because, how do I know that? Because that's where the graph changes direction, somewhere between 1 and 2, where it goes down through 2 and then turns around and comes back up. So between there must be a low point. So now I'll do my f prime table and figure out the rest of this. F prime, I've got about negative 1.58, and I'm just going to leave it like that. About negative 1.58, 0, and about positive 1.58. I don't need to be super duper exact. Okay? I just want to use these for when I am plugging in my stuff. But I do want to use my value when I'm actually finding the point. But these for just plugging in are going to work just fine. So I'm going to try negative 2, 1, sorry, negative 1, 1, and 2. Those are going to be my test points. I'm going to put them up in this guy right here. This guy right here. So when I do negative 2, I get a negative. And then this would end up being a positive, I believe, because it would be 4 times 2, 8, minus 5. Yep. So this would be a negative times a positive, so that's a negative region. That means I'm dropping. Then I'll try negative 1. Again, I'm plugging it in here. That'll make a negative for my first piece of it. Negative 1 squared is positive 1. 2 times 1 is 2. 2 minus 5 is negative, so that's a positive region. So it's increasing up to 0. Then I'll do 1. Positive, negative. Decreasing. And then I'll do 2. Positive, positive. Okay. I just eliminated fat parabola. So, I have a min at negative square root of 10 over 2, comma, something, and positive square root of 10 over 2, comma, something. I have a max at 0, 6. Zero, 6, I'll put on my graph right away. I wasn't very successful in finding zeros. It appeared like there were none. I did find a min, some mins and a max. So I'm going to get those mins in and see if I can evaluate those and get an idea of where those are going to be changing direction. So I go back up to the original. It is negative square root of 10 over 2 to the 4th minus 5 negative square root of 10 over 2 to the 2nd plus 6. This is 116ths minus 5 times 10 fourths plus 6. Looks like negative 1/4. Other one's the same. How do I know? Because even powers all the way across, so I don't even have to run through that problem again. So, here's 1, here's 2 on the negative side. I have a min at, we decided, negative 1.58, negative 1/4. And I have another min at 1.5, negative 1/4. It did cross the graph. In fact, it did cross twice on the left and twice on the right. It's just that it was such a tiny little move that it crossed before it came back up. It did not show up in my table. And again, that is why it is real important to take a look at your mins and your maxes as well, because that'll give you some final information. Now here, it's just a matter of connecting my pieces. Knowing that I can't cross again. Knowing what my end behavior is. Knowing there are no more mins and maxes. And done with that problem. Finally. Okay? So let's do homework problem. One of your homework problems, we'll run through that.